Let's take a look at some basic database design concepts. First and foremost, design first, then start your development. What does this mean? It simply means do not follow the design as you develop methodology. It will lead to development not going smoothly. Secondly, identify your requirements. Identify your required data components, such as entities, attributes, and relationships, prior to doing any development. Let's take a look at the definition of an entity. The term entity is often used instead of table, but they are the same. Entity is a real-world thing or a real-world object, which is distinguishable from other objects in the real world. For example, a car is an entity. Think of them as nouns. For example, in a school database, students, teachers, classes, and courses offered can be considered as entities. Every entity in a database must have a different name. It is common practice, but not required, to name entities in the singular. Attributes give us information about the characteristic features of an entity. An attribute defines the properties of a table, where each table has columns and rows. Each column contains characteristics that describe the rows. These columns are called attributes. Relationships are associations between tables that are created using join statements to retrieve data. Each table uses primary and foreign keys to relate records to tables. Some types of relationships are one-to-one, where both tables can have only one record on each side of the relationship. One-to-many allows a single record in one table to be related to multiple records in another table. Many-to-many, here each record in both tables can relate to none or any number of records in the other table. Using an entity relationship diagram shows the relationship of entity sets stored in a database. ER diagrams help to explain the logical structure of databases. ER diagrams are created based on three basic concepts: entities, attributes, and relationships. Try and start your design with an ER diagram. An ER diagram can be used as a roadmap for creating and maintaining a database. Let's take a look at what an entity is composed of. An entity consists of the following: an entity name, and a primary key, also known as PK. A primary key is a special kind of entity attribute that uniquely defines a record in a database table. In other words, there cannot be two or more records that share the same value for the primary key attribute, meaning there are no duplicates allowed. A foreign key, also known as FK, a foreign key is a reference to a primary key within another table. It is used to identify the relationships between entities. Note that foreign keys need not be unique. Multiple records can share the same values. Primary and foreign keys define relationships themselves. Attributes, also known as columns, consists of a column name and a data type. Note that supported data types can vary between every relational database. Here are some examples of different common database types. Let's take a closer look at an entity relationship diagram. In this example, we will define a set of entities that will support a relationship of a customer to a set of its orders. To do this, we will first define an entity and assign it the name customer. Then we will add a column and give it a name of ID, and assign the ID column as a primary key, and make its data type of type integer, followed by other required columns. Here the data type varchar 256 is a string data type with a variable length storage that has a maximum length of 256 characters. Then we will create the order table with its required columns. The date type datetime saves date in the time format of year, month, day, hours, minutes, and seconds. The money data type stores a currency amount with a fixed fractional precision. Here we also assign the ID column as a primary key. the customer ID column will be assigned as a foreign key that will be a reference to the ID column of the customer table. This is shown by using a one-to-many relation notation, also known as crow's foot notation. Let's take a look at the SQL syntax for creating a database and its tables. To create a database, it is simply create database followed by the database name. To create a new table, we use the create table followed by the table name. We then add the names of the columns and their data types. The not null means that this column must contain a value, meaning null is not allowed. AutoIncrement defines this column to automatically increment this value by 1 for each new record with a starting value of 1. Not null and AutoIncrement are optional. However, they are often used when defining a column in a primary key. The primary key will define which columns are to be assigned as a primary key. There can be one or more columns defined as a primary key. Foreign key defines which column in this table will be a foreign key. The references keyword defines which table and column it's going to reference. Note that this SQL syntax can vary for different databases. Let's take a look at an example for creating a database and its associated tables. In this example, we will use the customer and order tables we defined earlier in the Entity Relationship Diagram. First, we will create a database named Car Parts Company. Then we will create the customer table and assign the ID column as a primary key and include not null and AutoIncrement for this column. Then we will create the order table and assign the ID column as a primary key and assign the customer ID column as a foreign key, which references the ID column of the customer table. Let's take a look at an example for creating an SQL script. But first, let's look at the definition of what an SQL script is. An SQL script is a collection of structured query language SQL commands that are stored in a text file and performs an operation or task. Scripts reduce tasks that are usually repetitive, meaning they are executed over and over on a regular basis. Scripts can be saved and loaded when needed. They provide a consistent operation. If the script works correctly the first time, they will work correctly every time. They also provide a decrease in errors. Manually entered commands are susceptible to human error. Scripts reduce that possibility. Scripts can be scheduled to run at a time when it's convenient or when a human isn't present. In this script example, note the addition of if not exists. This prevents errors from occurring if the database or table already exists. We should note that Microsoft SQL Server uses a different syntax to check for the existence of a database or table and is shown here. Order of execution is important. The database must be created first, followed by its tables. In this example, the customer table is created first, then the order table is created because it references the customer table. If the order table was created first, it would cause an error since it references the customer table. The script file is saved usually with the extension of .sql. Here we will show a representation of how data is associated using the relationships based on the customer and order tables that we defined earlier. Here we'll have a customer table that contains one customer and the order table with the customer's order information. The ID value of 1 from the customer table has been placed into the customer ID column of the order table. This relation shows that there are 3 orders associated with this customer. Now let's add a second customer and add 2 orders that are related to this customer. Here, the ID of 2 from the customer table has been placed into the customer ID column of the order table. This relation shows that there are 2 orders associated with this customer. This representation is a depiction of how relations are formed between tables. I hope you found Introduction to Database Design Concepts helpful. If you have, click on the like button. To receive any updates to this channel, click on the subscribe button. Thank you so much for watching.